Today we're going to talk about probability of compound events. A compound event consists of two or more simple events. So example, choosing a white marble followed by a red marble. And the way I usually write this is probability of white and then red. So capital P stands for probability here. Independent event is the outcome of one event does not influence the other. And so usually the compound event A and B, you find the probability of the first one, you're going to multiply by the probability of the second one. If it's a dependent event, in other words, whatever happens second, something that happened first affects it, you are going to multiply the two probabilities, but you got to consider that this second one happens following A. And this will make more sense when we start doing examples. You'll see what I'm talking about. And then if they're called mutually exclusive, so you will be adding the probabilities. So the word or will be in there. So that's your clue when you have the word or that you're going to be adding. So let's look at an example, and they aren't really as hard as they sound. So you have a bag of marbles, and it's got 4 green, 6 red, and 2 white. This is one of the most important parts, is make sure you get the total right. So 4 plus 6 is 10, plus 2 is 12. So you need to have the total right, or that's going to throw all your problems off. And we're going to find these. We're going to draw one out at a time. We're going to look at it, and then we are going to replace it in this case. So in other words, they're independent. What happens on the first draw, if I put it back in, has no effect on the second draw. So what's the probability of drawing a green and then a white? So simple probability, how many ways can I draw a green? 4. Out of how many ways total? 12. So that was the first event. I drew my green, I look at it, put it back in. Now what's the probability of drawing white? Well, there are 2 ways I can draw a white out of 12. Now I'm going to multiply these, so remember it's going to be helpful probably if you do some canceling. 4 goes in there once, in here 3 times, once and 6. So we get 1/18. Squeeze problem 2 in here, so let's take it over here a little bit. Probability of red and then a green. So again, they're still replacing. So what's the probability of drawing a red marble? 6 ways we can draw red out of 12. We look at it, we put it back in. What's the probability of now drawing a green? 4 out of 12. Remember, you can do your canceling. Notice you could do them up and down. I usually do them diagonal, but you don't have to. Multiply what's left, you get 1/6. That would be the probability there. What's the probability of drawing green? Look at it, put it back in, then drawing another green. Well, how many greens? 4 out of 12. Look at it, put it back in, so they're 4 out of 12 on the next try. Each one of these reduces to 1/3, so you would get 1/9. Now this type of problem especially is going to be different. All of them will be different, but this one especially when we get to the second part. So pay attention to this next part now. Again, we have a bag of marbles, 4 green, 6 red, 2 white. This time it says without replacing. So we look at our marble, we set it aside, and we don't put it back in. So again, start with the simple probability. What's the probability of getting a white marble? Well, there are 2, and how many were there altogether? 12. We look at that one white we drew out, and we set it aside. Now, what's the probability of drawing a red marble? Well, there are still 6 red, but how many marbles altogether? 11. So that's how this changes, okay? So we can do some canceling. 6 goes in here once, 6 goes in here 2 times. We can also cancel this 2 with this 2. If you don't notice that, you're going to have to reduce in the end, and you get 1/11. So what's the probability of drawing a red, then red? And again, we're doing without replacement. So the probability of drawing a red the first time is 6/12. We drew a red, we set it over here to the side. So now what's the probability of drawing red? Well, we've already drawn a red, so there are really only 5 reds and 11 total marbles. Again, we can cancel this direction, and we're going to get 5/22. A spinner is divided into 8 even parts, and they're numbered 1 through 8. So what's the probability of getting a 7 or an even number? There are 2 ways to do this, but we're going to kind of do it this way that we said. So when we see the word or, we're going to be adding. So what's the probability of getting a 7 on this spinner? 1/8. And when we mentioned, remember, mutually exclusive, a 7 is not an even number, so you don't count them twice or anything. What's the probability of getting an even number? Well, 2, 4, 6, and 8 would be the even numbers, so that would be 4/8. You don't really want to reduce them first because now you got to add them, and you want them to have that common denominator. So you get 5/8. So that's how you would do that problem.